Hello, this is the instructions for how to complete the disease report for microbiology. So when we are studying diseases, we are specifically looking at the epidemiology of the disease. So the causes, the occurrence, the transmission, the distribution, as well as being able to prevent diseases that pop up in the population. One of the organizations tasked with collecting a lot of this data and making it public knowledge was the CDC, or the Center for Disease Control and Prevention. Now, normally in this project, what we would have you do is use the CDC website to look up the number of weekly cases that are happening with the disease that you're going to choose. However, due to a handful of things happening in the country, we don't have that information anymore. So instead of using the CDC website, I will provide you with a document that has a breakdown of the number of cases occurring from week to week for each disease on the list of diseases you can choose from. Now, in class, you will choose a disease specifically for yourself. It is first come, first serve. And what that means is if somebody else chooses malaria before you and you were really excited to do malaria, either you have to go talk to that person or you just have to choose something else. So that being said, you should not be working on this project until you actually sign up for the disease that you're going to do your project on, because there can't be any repeats. So again, kind of what I said, we are going to be using a PDF file that I will have posted on Brightspace for you instead of the CDC website, so that you can collect all of that data from that document, as opposed to not being able to find it because it is no longer on the CDC website. So we are using information from 2024, and that is because there is no information for 2025. The CDC no longer has that information from previous years. This is actually something that we had to compile very quickly in order to have that information. And then we don't have that information for 2025. Diseases are not being reported. We do not know the number of cases week by week in the United States of who's getting sick and where. So little concerning, but either way, moving right along. There are a handful of important terms as well as equations when it comes to epidemiology. The primary one that we're going to focus in on is the incidence rate. So this is the measure of number of new cases of a disease in a population within a specific period of time. We could also look at morbidity or prevalence rate, as well as the mortality rate. But for this project, we are going to focus in on that first equation, the incidence rate, and I promise I will show you how to use it. These equations are in your lab manual, but if you want to just keep watching, I'm going to show you how to use it. Okay, so with your data that you have to collect, as well as some calculations that you have to do, there is a chart in your lab manual. I think it's 2 pages into the disease report lab, and you will see that it is broken down into 52 weeks, and those 52 weeks are then broken down into 4-week totals. So we are going week by week and also breaking those weeks into months. So the first thing you're going to do is look at how many cases there are from week to week. Now, keep in mind that there is a term here, and I'm going to underline it in orange. It is cumulative. This number that we're going to see as it moves down into the weeks is going to be additive. So in week 3, we see 1 case, 1 new case. By week 4, we see 2, except this is total number of cases. So there are now 2 cases. There was 1 case in week 3 and 1 case in week 4, giving us a total of 2. Now that does cut off that 4-week period, and what we see is 2 total new cases for that 4-week period. When we move further down, we're looking at week 5, and we see that there are now 3 cases. That means that there was 1 more case added to the 2 cases that we saw in the first 4 weeks. By week 6, we are only still seeing 3 cases. That means that there are no new cases by week 6. By week 7, there are now 4 total cases. That means we have 1 more case that's been added in week 7, and in week 8 there were no new cases in that time period, so there are still only 4 cases in total as of that 8-week period. So what we're going to do to figure out how many new cases there have been, we're going to take this number at the end of week 8, and we are going to subtract the number from the previous week. So we have 4 minus 2, and that gives us 2 new cases in the second 4-week period. All right, from there we go to week 9. There's still only 4 cases. That means there's no new cases there. And then week 10, we get kind of a jump here, and we end up with 8 total cases, meaning we have added, and I'm so sorry, this is so ugly, 4 new cases. By week 11, we have 12 cases now. So we have added 4 again. And then on week 12, we end up with 20. So that tells us we added 8 new cases. There are 20 cases in total, but we have now added a handful of new cases. Now you could keep track of your new cases kind of like this, or you could do the math, and it's really pretty easy math. So you just take the number that is that bottom line here of our total cases, and then we minus the number of cases that we ended up having at the end of that previous week. So that gives us a total of 16 new cases. Now, from there, what we're going to do is we're going to take the number of new cases and we are going to divide it by the U.S. population size as of July 1st, 2024. So for this first 4-week period, we're taking this number 2, because that is the number of new cases, and just dividing it by this population size, which is something that you can just Google. It's just a very Googleable number. In the second month or 4-week period time, we're going to take that number of new cases, divide it by the U.S. population size. It's going to be the same number over and over as far as what we divide by. And then in that 3rd week, we're taking 16, dividing it by that U.S. population size. So this number that we are calculating for the incidence rate, this is telling us that per person, it is how likely that person is to get sick with the disease. Now, this number really does not tell us a whole lot of information. It's not very helpful because if we did the math, and let me show you over here, if we did the math, we'd get a really tiny number as far as this incident rate, because it is a rate. It would mean that you have a 0.00000000016 chance per person of getting sick. And that's not crazy great. So we convert the number by multiplying it by 1,000,000, and that gives us 1.6 people out of 1 million will get sick. And that is the rate that we do want to see. You just have to be consistent when you convert your numbers to convert it by the same number, some factor of 10. My recommendation, make it 1 million. Let's take a little bit of an example here of what you might see when you do the math. So let's say that there are 312.6 million people in the US as of July 1st, 2024. That is not the correct number. Please don't use that number. You will have to Google it. But let's say that it was. We are going to take something like 2 new cases divided by 312.6 million. What your calculator might spit out is either some number with a -9, which is telling us that there are 9 zeros before the 6. Now, I don't want you to think that that is like the final number. That is saying that there is a decimal. It's a very small decimal. However, your calculator is giving you that number in kind of a nicer way. It's just moving the decimal point. Or it's going to give you 0.00000 and so on until you get to the actual number part. But it's a very small decimal. We just need to change where the decimal point is and make it something like 6.39, or you could round and put 6.4. And then the way we would phrase it is 6.4 people out of 1 million will get sick with whatever this disease is. So just to kind of give you a heads up that that is what that could potentially look like in your calculator, and not to be concerned about it. Remember, you do just want to move that decimal point the same number of times on every single calculation that you do. Be consistent. That's why I'm saying multiply it by 1 million. That will make your life easier in the long run, I promise. So on your data chart, I do want you to show in that final column your work. So that way, if you are incorrect with your numbers, at least I can give you some points and see where you went wrong. Because if you show me your work, life will go much easier for you, I promise. So if you can put it on a separate piece of paper. You can write it in that small space if you really want to, if you have tiny handwriting. Otherwise, an extra sheet of paper is perfectly fine to add to this report. The next thing you're going to do with all of that data and your calculations is to put it into some graphs. So I do want to see a graph that looks something like this. You are going to have to include all 52 weeks for one of your graphs, and the other one is going to have a smaller amount of data points. Make sure that you are labeling your axes, putting units on your axes, and then also just being very clean and clear as much as you can with your graphs. If you have questions about making a graph, please let me know. You can use the paper that I've provided in the lab manual. However, you're more than welcome to make your graph look pretty. If you want it to be more digital, you can go on the computer and make a very pretty graph. However you want to do it, I don't care. But if you want to keep it simple, just use what I've provided and just draw it out with your hand. This project is worth 50 points. You do have a little bit of time to work on this, about 2 weeks-ish or so, and given any semester. But if you want to check that date specifically, you will have to check your schedule for that specific due date. You are always welcome to turn this in early, and I will grade it very quickly, get it back to you, get your points in Brightspace. It shouldn't be too bad of a project, if I'm honest with you. If you have any questions, though, please just let me know. Remember, you cannot start working on this project until we cover it in class, and I open up the class to choose their specific disease. The last page of your packet for this lab is going to have you describe your disease very briefly. If you use any type of external source, just make sure that you cite that source. If you use our notes, you can just say that you use the notes from class as well. So I do want that handwritten, preferably not typed. and then you're just going to have to staple everything, turn it in by the time it's due, or turn it in early. If you have any questions, please don't hesitate to let me know. I am happy to help with it.